My research is about toxicology. I'm a toxicologist. I study poisons, how they work, where they work, and what they do in different environments. At the moment, I'm working on agricultural poisons. So I work with farmers and anyone involved in the agricultural sector to address any sort of poisoning or stop poisons getting into our environment or something like that. At the moment, my main project is actually working with the toxic Swedes in Southland. We had an outbreak in 2014 where there were about 400 cows that died within a 6-month period. And my job is to kind of go in and figure out, well, what happened, where did it happen, what's going on, with the idea of telling the farmers, can I plant Swedes, can I not? What happened in that year? What do I do? Can I continue to grow this crop, and what do I need to watch for? So if we can give them some very good advice about those things, then we can protect them in the future. But it's about protecting our kind of rural livelihood. It's a huge part of our economy and I want to protect that. I'm also a strong environmentalist, so I have a really strong desire to protect our environment. So if we're doing something to our environment that is toxic or damaging, then I want to find ways that control that but maintain livelihoods for the farmers, because we can't just kind of say, no, you can't grow anything, no, you can't put pesticides on. That's not reasonable. Can we protect the environment and have good outcomes for farmers? I'm a very applied scientist. I love that direct link between this is what I do, this is the people that I'm helping. I couldn't get out of bed if I didn't have a reason and a drive to help people. That's what I want to do. I want to help our planet, I want to help the people around me. And my science does that. That's how I can contribute my little bit. Obviously, we're going to get our students very good training in terms of their academic pathway. So students that come in and work with me, they're going to get a good, rigorous grounding in how to conduct a scientific investigation. And that's highly transferable. It doesn't really matter if you keep going in toxicology, whether cows float your boat or not, that's fine. But you're going to come out with a set of skills of this is how you solve a problem like this, which is really important. The other thing is they are going to help some people. And the students that I have had love that applied link. They love the fact that we get out there, we talk to farmers. We've been down to the meatworks and talked to the guys down at the meatworks about different things. We work with vets. I'm off to field days to just kind of talk to people about what's happening. So we're not shut in the lab. We're not kind of sitting just behind a microscope all day. You can do that if you like, but if you want to meet people as well, I'm happy to give you chances to go do that. We really are at the cutting edge of helping a whole heap of people. When you think of the scope of a new drug and the potential of that to really actually help somebody or to really have an impact on an environmental problem or something like that, that to me is huge. What a thing to do with your life. The other thing is it's fantastically exciting. You get bitten by the bug. I didn't come in thinking I was going to be a pharmacologist or toxicologist. Actually, I thought I was going to be a vet. And I just got bitten by the toxicology bug. I just love finding out about all of these poisons out there that'll do you harm. It's an exciting subject. It's changing, it's moving, there's new stuff happening, and it really has the potential to change people's life. You know, you think about working on something like cancer. God, if we could make cancer therapy better, just a little bit, that'd be awesome. If we could clean up one river in New Zealand, then that would be great. Be cool.